Hello and welcome to Mr. Barton's autograph video number 34. Now this week, as promised, we are going to take the lovely 2x2x2 cube that we constructed last week and start looking at some of the nice things we can do with it, starting with Pythagoras and Trigonometry in 3D. Now if you don't have a lovely 2x2x2 cube sitting in front of you, you need to nip back to last week's video number 33 and that will take you through how to construct it. Okay, so here's my video and let's begin our look into Pythagoras and Trig in 3D. Now the first thing is I'm a bit fussy, and although it looks lovely with all its different colours here, for clarity I'm going to make all the colours of the vertices one colour. Okay, now Marquee Select is a bit dodgy in 3D because if you try and do it you end up just spinning around the axes, so Marquee Select's out of the question. So we're going to do the old-fashioned, move up to edit, we're going to go for select all because we want absolutely everything, everything's covered there, and I'm just going to change the colour, so I think I'll go for something like a lovely blue. Now all the points change, all the sides change, and that's absolutely fine, looking nice. The next thing, if I'm talking kind of geometry and for Pythagoras, I'm not really keen on having these axes, so I think I'm going to get rid of those. So let's go up to edit axes and let's go to options, and I want no axes please, and then I'm left with a lovely cube. Now, a few things you should be aware about autograph in 3D is that text boxes don't work. But that's not a problem. If I want to know the length of that line segment there, it does appear in the bottom of the screen here, but it's a bit small. So if you give that a little double click, then you get the nice status box that floats. So that has got side length 2, and we can tell the students that our entire cube is a 2x2x2. Okay, I'm just going to close that down for now. Now, when we come to look at Pythagoras in 3D, it's often quite tricky for students to grasp and to visualise, and I find it quite difficult myself. So a kind of problem we could present students with is how would we find the length of this line segment. So I'm going to select that point there, and I'm going to select that point there in the opposite corner, right click, and hopefully down the bottom I have a line segment. How would we find the length of that? Oh, and of course, because it's in 3D, we can have a lovely little look around the side of it. Now, you may need to give your students a bit of a hint here to get them rolling and encourage them to see if they can spot a right-angled triangle anywhere in the cube. And eventually, hopefully, they'll spot that if you click on that point and click on that point and right click and do a line segment, well, there's the right angled triangle that we need. And then we can start thinking how we can work out the length of this brownie line, and then how that will help us with the light blue line. Okay, now once they've done all the Pythagoras on it, if you want to check it using autograph, that's not a problem at all. If you just click on that brown line and then double click on the bottom, there's the distance there, and I think if my maths better not let me down here, but I think that's 2 squared plus 2 squared, which is 8 square rooted, so I think that's the square root of 8 there. Now, one thing I should say very quickly is that if you find you're getting inaccurate answers like 2.8 or something, you're going to have to change your preferences. If you just go to View and Preferences, and if you click in General, you can change the accuracy. So I've got mine pumped up to 9 significant figures. So once they've, just remove the key there. So once they've worked that out, again, then it's you can use that length in the following calculation to work out the length of that bit. And again, if you double click, that comes out nicely. Well, not nicely actually, but to that length there. But whilst you're on a roll with Pythagoras in 3D, why not do a bit of trig in 3D? So we can actually work out the size of that angle there. Now in 2D you select 3 points, that point, that point and that point, but in 3 dimensions that's not what you do. In 3D you select the 2 line segments, so I give that line a little click and I give that line a little click and I right click and I get angle between lines, and that appears in the result box down here. Now I've been doing a few calculations before this video started recording, but that's it there, 35.26 degrees, and notice I am in degrees on the top there, not radians. Okay, so there's how you can have a little look at Pythagoras and Trig in 3D. You don't have to restrict yourself to cubes. I did a little cuboid here that you can build up, so I'll just get rid of that. I also did a prism there that you can have a look at, a triangular prism, and I also did a lovely pyramid, and that sets yourself up for nicely going through some of those nasty exam questions. And the beauty of doing it on autograph is you can have a whiz around it and have a look and convince the students that the shapes you're working with are right angled triangles, and therefore Pythag and Trig are perfectly legit to use. I'm out of time. Hope that was useful. See you next week. Bye bye.